Now, next problem, find VO of t where the initial value of IL is equal to 0. First, let's convert the circuit into the frequency domain. So we have voltage source, the value of 25 over S plus 2. We have a resistor, an inductor, 2S. We have yes, and this is VO. Before solving, we can combine these two branches, 2S and 2. So they are connected in parallel. So ZEQ is equivalent to 2S parallel with 2. So we have 4S over 2S plus 2 or equal to 2S over S plus 1. Now solving for VO, we can use VDT. By VDT, VO is equal to ZEQ over ZEQ plus 1. So we have 2S over S plus 1 all over 2S over S plus 1 plus 1 times the voltage source. So this is equivalent to 2S over S plus 1. We have 2S plus S plus 1 all over S plus 1 times 75 over S plus 2. So VO just 150 S over 3S plus 1 times S plus 2, or this is just equivalent to 50 times S over S plus 1 over 3 times S plus 2. Now using partial fractions, 50S over S plus 1/3 S plus 2 is equal to A over S plus 1/3 plus B over S plus 2. We have A plus 2 plus B S plus 1/3. Now if S is equivalent to negative 1/3, A is negative 10. Now if S is equal to negative 2, B is 60. So we have V of S equal to negative 10 times 1 over S plus 1/3 plus 60 1 over S plus 2 volts. Now converting this into time domain, we have negative 10 e to the negative t over 3 u of t plus 60 e to the negative 2t u of t volts. Or we can rewrite this as 60 e to the negative 2t minus 10e to the negative t over 3 u of t volts. Have our final answer. For the next example, find the value of the voltage across the capacitor, assuming that the value of Vs of t is 10 u of t volts, and assume that at t equals to 0, negative 1 flows through the inductor and positive 5 is across the capacitor. So we have, assuming this is the direction of IL, we have IL 0 equal to negative 1, and then V of 0 equal to 5 volts. So again, our first step is to convert the circuit into frequency domain. We have a voltage source, the value of 10 over S, we have 10 over 3, and we have, so this time there are initial values, so we can either choose either of the two configurations or equivalent circuits for the inductor and capacitor. For the inductor, let's choose the inductance in series with the voltage source. We have this configuration. So this is 5S, and then we have negative 5 volts, because this is equivalent to L times the initial value of IL, or initial value of I. Then we have inductor series with a voltage source. So this is 10 over S. Then we have V0 over S, or this is equivalent to 5 over S volts. And this is the voltage across the capacitor. So take note that in the frequency domain, we should include the initial value. So the voltage across the capacitor should be here up to here, not just the voltage across this. So the voltage that we are trying to solve is this voltage, not just this voltage across here. So we can use nodal analysis to solve for this circuit. So applying KCL at VC, we have VC minus 10 over S over 10 over 3 plus VC minus 5 over 5S plus VC minus 5 over S over 10 over S equal to 0. So combining VCs, have 3 over 10 plus 1 over 5S plus S over 10 equal to 3 over S plus 1 over S plus 1 half. We have VC equivalent to S squared plus CS plus 2, and we have 10s equal to s plus 8 over 2, 2s. So this cancels out, becomes 5. Our expression for VC equal to 5 times s plus 8 over s plus 1 times s plus 2. Using partial fraction, we have a over s plus 1 plus b over s plus 2. Now solving for the value of a and b, right? This here, 5 times s plus 8 equal to a s plus 2 plus b s plus 1. We let s be equal to -1. You can solve for the value of a equivalent to 35. We let s be equal to -2. B is -30. Yeah, 35 and 30. And our expression of VC is equal to 35 over s plus 1 minus 30 over s plus 2 volts. Converting this into time domain equal to 35 e to the negative t minus 30 e to the negative 2t times u of t